Bismillahirrahmanirrahim. Today we will discuss about myocardial action potential. During our first year life, I personally suffered a lot regarding this. So let us make it easy. Before discussing this, we need to understand what is depolarization and what is repolarization. First, depolarization. It is due to influx of positive ion. So membrane potential reaches to positive value. Now, repolarization. It is due to efflux of positive ion or influx of negative ion. So membrane potential reaches to negative value. Now the myocardial action potential. If we plot a graph of membrane potential against time, we see this type of graph of ventricle muscle. It is divided into four phases: phase 0, phase 1, phase 2, phase 3 and phase 4 respectively. First, the phase 4 or the resting phase. Here in this phase, the membrane potential remains at resting membrane potential. Due to presence of gap junction, the resting membrane potential reaches from -90 mV to -70 mV. Here in the ventricular muscle, there is presence of gap junction which causes entry of calcium ion. As it is a positive ion, it causes depolarization. The resting membrane potential -90 mV increases to -70 mV in this graph. This 70 mV is called the threshold potential. As it reaches the threshold potential, the phase 0 will start. Now the phase 0 or the depolarization phase. Here the resting membrane potential reaches to threshold potential, then sodium channel will open, which causes influx of sodium ion, and membrane potential rises from -70 mV to +20 mV. Here we see that the voltage gated sodium channel is open and sodium influx occur. So due to rapid entry of sodium ion, the membrane potential is due to depolarization reaches from -70 mV to +20 mV. Now the phase 1 or the initial repolarization phase. As the membrane potential reaches to the +20 mV, the voltage gated sodium channel is closed. Now, as the voltage-gated potassium channel opens up, leads to potassium efflux from the cell. So positive ion will be lost from the cell and repolarization starts. Here we see that the sodium channel is closed and the potassium channel has opened up, which causes potassium efflux. In the graph, we see that the graph is going down, which means repolarization is going on. Now the phase 2 or the plateau phase. Here the voltage-gated calcium channel opens up, leads to calcium influx, which is positive ion, which balances the loss of potassium ion loss. So both depolarization and repolarization occurs in this phase. In this figure we see that the calcium channel has opened up, leads to calcium influx. Beside there we see the potassium efflux is also going on. So in the graph, the membrane potential remains quite stable, which is called as the plateau phase because it is as flat as plateau. Now the phase 3, the late repolarization phase. Now calcium channel closed only, the potassium channel remains open, which causes the efflux of potassium ion. As positive ion is going out, so repolarization occurs again. Here in the figure we see that only the potassium channel is opened up and all are closed, so potassium efflux is occurring. So in the graph, the membrane potential has fallen down back to resting membrane potential, which is -90 mV. That is, only repolarization is going in this phase. Now the phase 4 again, the resting phase. Here the membrane potential reaches to the resting membrane potential and all the channels are closed. In the figure we see all the channels are closed and only the gap junction is open, which I stated earlier, and finally the graph looks like this, and by this way the cycle will continue. Thank you for watching. If you like it, please share and subscribe to my channel.